Again, this is a past final question. Honestly, this is a very easy question considering it's a final question. Finals are actually quite straightforward in my opinion, most of the time. So yeah, just rewriting the set here. So here the relation is defined on the reals. A and B are related if and only if A and A minus B the whole square is less than 4. So that's the definition of the relation. So is it a reflexive function? I.e., for every real number, is it related to itself? Again, for the actual answer, you don't, if it's actually false, you don't have to write all of them. You just have to write which one is false. But since we're doing it in tutorial, I'm going through all of them. So is this reflexive? How do you check? I'm going to call this, oh, this is how the this is defined. Yeah, it is reflexive. Why? Pick any x in the reals. How do I know if it's related to itself? It's related to itself if it follows this definition. This is the definition of the relation. Two numbers are related if it satisfies this equation. Excellent. So that means x minus, need more space, x minus x the whole square is equal to 0. This is less than 4. This means x is related to x. Okay, so it is reflexive. Is it symmetric? What's my assumption in a symmetric? Assume x is related to y, where x and y are real numbers. Awesome, it is symmetric. Okay. So what does this tell you? If x is related to y, this tells me x minus y the whole square is less than 4. Okay. Now, where do I go from here? So I need, I want to see if, can I get here? This is basically what I'm trying to see. Can I fill stuff here to get this? If yx is related, what should my second last line be? What should I get here to make this conclusion? Yeah, if I should get this conclusion, I should get here y minus x squared is less than 4, because that's the definition of this relation. So now the question is, can I go from here to here? What do you guys think? So this is what I have. So I have the stuff in yellow. Question is, can I go from the yellow to the orange highlighted to fill in the blanks? If yes, that means we finished the proof. If not, then that means there's something missing and we need to do the counterexample. So I have x minus y the whole square is less than 4. Is it true y minus x the whole square is less than 4? Guys, this is like grade 2, grade 4 math. First time ever when you learn squares, you know, you learn the answer to this question. What's the relationship between x minus, yeah, y? Because what's the relationship between x minus y squared and y minus x squared? Guys, the squares of negative numbers is the same. Okay, so y minus x squared is just minus of x minus y. Okay, so minus is irrelevant. When you square a number, it's like saying 1 square is less than 4, minus 1 square is less than 4. Negatives have the same square. That's why you can do this. Does that make sense? I'm very confused why that was that took, like, why no one said that answer. Like, I thought that was a very, very obvious and simple thing, which obviously it might not have been for you. So is there something that confuses you guys in that? Okay, I'm gonna give you guys time to think about transitive. And at the same time, if you have any doubts, just ask me. So if it is transitive, this is what I will have. I'll assume X and Y are related and Y and Z. Again, guys, if you have any doubts, just put in the chat, okay? X, Y, and Z are real. This tells me X minus Y the whole square is less than 4. And Y minus Z the whole square is less than 4. So that's my assumption. I need to conclude X minus Z square is less than 4, which tells me X is related to Z. So my question is, can I actually do this? If yes, then how do I do that? And that's it, and that's your proof. If not, then that means it's not transitive. So give me a counterexample. Okay, I have someone who already gave me an answer. If you have an answer, I'm going to give a few more minutes for people to think, but the one who did answer, okay, people are starting to answer. Okay. Okay, let's see. So yes, it's not transitive, and it's great that you guys are seeing this. And I see a few counterexample. So this is not possible. So we are not doing this. No, not transitive. So to be honest, if this was when this was a final exam question, you didn't need to do these two. Like, you don't need to show it's reflexive and symmetric, because your answer is it's not an equivalence relation because it's not transitive. So all you had to do was this part. So awesome. I see a few examples. I just want to caution the order in which you write X, Y, Y, Z. So the common element should be the Y elements, okay, not the X and Z. And this is to the person who private messaged me the solution. So your common element should be the Y, not the X element and the Z, okay? So not transitive, and a few examples. So let me just choose the first one that was sent as the example and see if that works. Let X equals 2, Y equals 1, Z equals 0. They're all real numbers, great. X minus Y the whole squared equals 2 minus 1 the whole squared, which is 1, which is less than 4. Y minus Z the whole squared is equal to 1 minus 0 the whole square, which is again 1, which is less than 4. So this means X is related to Y. This means Y is related to Z. Awesome. So we have X and Y related, Y and Z related. But X minus Z the whole squared is 2 minus 0 the whole square, which is 4, which is not less than 4, which means X cannot be related to Z. So what we basically did here is we found X, Y, Z in the reals such that you don't need this line. This is just so you can understand. We found X, Y, Z in the reals where X is related to Y and Y is related to Z, but X is not related to Z. Okay, so this means it's not transitive. So it's not an equivalence relation because it's not transitive. Any questions in this? If there is no question, start doing question 4. If there is a question, just ask me in the chat. Okay, if you guys end up doing Math 202, you're going to see this a lot. Actually, most in the next step is, I would say, like modular arithmetic is so common. Like you'll see it in every upper year math course, but Math 202 is the course like pretty much dedicated half at least to this. I think it is 202. So basically, you need to know what this notation means for the next part. The counterexample. So actually, let me comment on that. So there is no right method because it really, finding the counterexample depends on the equation you have. To change the equation, the method changes drastically. There is no one way. It's not specific to relations or anything. It's literally trying to find the values at work. You become better at it the more practice you do in math. The more math you do, the more better you get intuition. But in my brain, I was like, first I tried to see, is it possible to do this jump? And I couldn't see any way I could make it. So I was like, okay, maybe it's not true. Can I come up with a counterexample? So the logic I had was, okay, if I have two numbers which difference square is less than 4, what makes it, like, remember when you want a counterexample, you want x, y, and z. Y is a common element in this. Okay, so when I thought of the numbers, I personally, the counterexample I came up with when I did this was 1, 0, and 0 minus 1. The reason I do that is whenever I have a common element, I try to make that 0 or 1 or something that's very easy to work with. And then I try to manipulate the other two to see, can I manipulate the other two to get a counterexample? That's how I approach it. Like I always say, okay, this is the common number I want. How do I make that very simple and fixed and try to manipulate the other two? Yeah, and that doesn't always work. It works here. But the strategy, that's like a starting strategy, I would say. And then you just do lots of examples and you kind of get better at it as you go. Does that kind of help? Okay, awesome.